Can a moon vanish? That was the question that once plagued astronomers as they peered through primitive telescopes in the 1600s. What they saw, or more accurately, what they didn't see, defied all logical expectations. On certain nights, Saturn had its usual number of moons visible, but on others, one of them seemed to simply disappear, as if it had slipped behind a cosmic curtain. This wasn't an illusion or equipment failure. The moon truly went missing, at least from our vantage point, and it did so with eerie regularity, every 79 days. What kind of celestial body plays hide-and-seek across the vastness of space? What force could cause a whole moon to flicker out of existence only to reappear again later? The answer, as it turns out, is more bizarre and more beautiful than anyone could have imagined. The story begins in 1671 when Giovanni Domenico Cassini, an Italian-French astronomer working at the Paris Observatory, turned his newly built refracting telescope toward Saturn. There, orbiting the gas giant, he spotted something unusual, a tiny moon not previously recorded. Over time, he tried to track it, expecting it to move in predictable patterns like the other moons. But this one refused to obey the rules. When it was on the western side of Saturn, he could see it clearly. But when it moved to the eastern side, it vanished completely. At first, Cassini questioned his instruments. Then he questioned himself. Was he hallucinating? Was there some atmospheric distortion hiding the moon? But every test yielded the same result. The moon was only visible from Earth when it orbited to the western side of Saturn, and then, like a magician's trick, it would vanish again for weeks on end. Eventually, Cassini came to a revolutionary conclusion, one that would rewrite how we understand not just moons, but the very mechanics of celestial bodies. The moon he had discovered, which we now know as Iapetus, must be tidally locked. That is, it always presents the same face towards Saturn, just as Earth's moon always shows us only one side. This meant that one hemisphere of Iapetus faced forward in its orbit, the leading hemisphere, while the other trailed behind. But what truly shocked Cassini was that the moon wasn't vanishing due to distance, eclipse, or obstruction. It was vanishing because of color. Cassini hypothesized that one side of Iapetus must be far darker than the other, so much so that when the dark side faced Earth, the moon reflected so little sunlight that it became virtually invisible through 17th century telescopes. When the bright side faced Earth, it reflected enough light to be seen easily. It was, without a doubt, one of the most groundbreaking observations of the era, the first time a surface feature of a moon beyond Earth's had been detected using telescopic observation. He named the moons he discovered Sidera Lodoicea, honoring King Louis XIV. But decades later, in the 19th century, British astronomer John Herschel would rename the Saturnian moons after mythological figures. He chose Iapetus for this mysterious, disappearing moon, after the Titan father of Atlas and Prometheus. It was a name befitting a celestial body steeped in ancient mystery and modern enigma. For the next few centuries, Iapetus remained an object of fascination and frustration. Telescopes improved, and new moons were discovered. But Iapetus continued to defy easy explanation. Even the groundbreaking Voyager missions in the late 1970s and early 80s, which revolutionized our understanding of the outer planets and their satellites, only managed to capture distant, low-resolution images of Iapetus. Voyager 1 confirmed the stark contrast between the moon's hemispheres, and Voyager 2 hinted at something even stranger, a faint equatorial ridge. But the full picture wouldn't emerge until NASA's Cassini spacecraft arrived at Saturn in 2004. Named in honor of the same astronomer who discovered Iapetus, the Cassini probe was equipped with far more advanced instruments than anything humanity had ever sent into deep space. In 2007, it performed a daring close flyby of Iapetus, passing within just 1,640 kilometers of its surface. What it revealed stunned scientists. Iapetus, it turns out, is a world of impossible contrasts. Its density is extremely low, only about 1.2 times that of water, which means it's made up mostly of ice. As much as 75% of its bulk is frozen water, locked in a rigid ancient shell. Its surface is battered by countless craters, indicating it's geologically dead. No internal heating, no cryovolcanism, no resurfacing activity like we see on Europa or Enceladus. It's a frozen relic, largely untouched since the early days of the solar system, but its physical shape was even stranger. Cassini revealed that Iapetus has a distinctive walnut-like appearance. Across its equator stretches a mountain range, a ridge over 1,600 kilometers long and up to 20 kilometers high, running almost perfectly along the moon's midsection. Eddie, no other moon or planet in our solar system has anything quite like it. It looked as if someone had taken a sphere and squeezed a belt of mountains around its waist. The mystery of the ridge's origin became the subject of intense scientific debate, but more immediately pressing was the question of Iapetus's two-faced surface. Cassini confirmed what telescopes had suggested for centuries. One hemisphere of the moon is pitch black, reflecting as little as 3 to 5% of sunlight, while the other is blindingly bright, reflecting 50 to 60%. A difference so stark it seems like two different moons stitched together. The dark region is known as Cassini Regio, in honor of its discoverer. It dominates the leading hemisphere, the side of Iapetus that faces forward in its orbit around Saturn. The trailing side and polar regions are much lighter, coated in pristine ice. But what could cause such an intense dichotomy? The first idea scientists explored was that the dark material came from inside the moon itself. Perhaps volcanic activity or internal melting had brought darker ices or minerals to the surface. But this theory didn't hold up under scrutiny. Cassini's sensors showed that the dark coating is incredibly thin, just a few centimeters to a meter thick in most places. Craters that punched through the surface revealed brighter ice underneath, proving the darkness was only skin deep. The next theory was more compelling and far more cosmic in scale. The dark material, it turns out, likely came from outside Iapetus. Evidence pointed toward Phoebe, one of Saturn's outer, irregular moons. Unlike most of Saturn's moons, Phoebe orbits in the opposite direction, a retrograde path. Over billions of years, impacts on Phoebe and similar moons have ejected fine dust particles into orbit. These particles form a vast, tenuous cloud known as the Phoebe ring, which slowly spirals inward toward Saturn due to a process called the Poynting-Robertson effect. In this subtle but powerful phenomenon, solar radiation causes small dust particles to lose angular momentum and drift inward over time. Iapetus, orbiting in a prograde direction, effectively plows into this retrograde dust with its leading hemisphere. This makes the front side of Iapetus act like a cosmic snowplow, gathering more dark material than the trailing side ever encounters. This continuous bombardment coats the leading side with dark, carbon-rich compounds, similar to those found in primitive meteorites like the Murchison meteorite here on Earth. But why is the darkness so intense? Why the dramatic contrast between the hemispheres? That question would lead to an even deeper mystery, one involving heat, ice, and a strange feedback loop that turns slight differences in temperature into monumental changes in appearance. The secret to Iapetus's duality lies in the power of thermal feedback, a cycle so simple, yet so potent, that it reshapes entire landscapes over eons. The dark dust coating the leading hemisphere absorbs sunlight far more efficiently than the bright, icy surface on the trailing side. That extra heat doesn't just warm the surface. It triggers a sublimation process where water ice transforms directly into vapor, skipping the liquid phase entirely. And because space around Iapetus is a near-perfect vacuum, that vapor doesn't hang around. It escapes into space, or it migrates. Here's where the cycle kicks in. As ice sublimates from the dark, warmer side, it tends to redeposit onto colder regions, mostly the brighter trailing hemisphere and polar areas. Over time, this redistribution causes the dark areas to become even darker because they're losing ice and concentrating the residual dust. Meanwhile, the bright areas get even brighter as fresh ice accumulates. The contrast becomes amplified by its own physics. A small initial difference turns into a dramatic visual transformation. It's a runaway albedo effect, the same kind of mechanism that drives climate feedback loops on Earth. Except on Iapetus, it's happening at a planetary scale, sculpting one half of the moon into a shadowy, light-absorbing canvas, and the other into a gleaming, frosty reflector. And this asymmetry doesn't just affect its appearance. It affects visibility from Earth, explaining why Cassini couldn't see it when the dark side was turned toward us. But that's just the beginning of Iapetus's anomalies. Let's talk about that equatorial ridge again, the so-called Great Wall of Iapetus. Why would a frozen, inactive moon have a singular mountain range stretching neatly along its equator? There are several competing theories. One suggests that the ridge is the remnant of a collapsed ring system. At some point in Iapetus's early history, it may have had a ring, a transient band of icy debris held in orbit. But because Iapetus's gravity isn't strong and its shape is oddly oblate, that ring could have slowly lost altitude and rained down along the equator, forming a pile of rubble over millions of years. The result, a belt of mountains exactly where the ring would have hovered. Another theory proposes that Iapetus once spun much faster than it does today. Early in its formation, it may have rotated once every few hours. That rapid spin would have created a pronounced equatorial bulge, just as Earth has a slight bulge at the equator due to its spin. Then, as Iapetus cooled and solidified, it locked into synchronous rotation. The bulge froze into place, preserving a record of its former, faster spin rate. Over time, the uplifted equatorial region could have fractured and deformed into the ridge we see today. And yet another hypothesis suggests cryovolcanism or even upwelling of materials from the interior. But this clashes with Iapetus's current inactivity. There are no signs of ongoing tectonic movement or internal heating that would drive such dramatic uplift. It's as if the ridge is a fossil, a frozen memory of something ancient and fleeting, a brief moment in geological time captured like a scar on an otherwise silent moon. Whatever the origin, the ridge adds to Iapetus's status as a cosmic oddity. No other moon in the solar system has anything quite like it. And it's not just the size or shape, it's the sheer alignment. The ridge hugs the equator so precisely that it looks artificial in some high-resolution images. Some theorists, not mainstream scientists, but fringe researchers, have even speculated that it might be evidence of ancient engineering. A vast wall built by some forgotten intelligence. While there's no credible evidence to support such a claim, the idea reflects just how alien Iapetus appears. It doesn't look like a natural object. It looks designed. And here's where things start to get even weirder. During Cassini's closest flyby, scientists noticed something strange about Iapetus's craters. Normally, on a moon made mostly of ice, you'd expect to see softened crater walls, especially if sublimation is active. But on the dark side of Iapetus, the craters were crisp and angular, like they'd been carved yesterday. That shouldn't be possible. It's likely that the darkness preserves these features, shielding them from the same ice migration that smooths out craters on the bright side. But it adds to the eerie visual contrast. One hemisphere looks ancient and ghostly, the other looks harsh and fresh. Then there's the shape of Iapetus itself. It's not quite spherical. Instead, it's noticeably flattened at the poles and elongated along the equator, a shape more consistent with a spinning object that's suddenly been frozen in time. It's not what you'd expect from a small, icy moon in a quiet orbit. Taken together, the dual coloration, the towering equatorial ridge, the preserved craters, the bizarre shape. Iapetus doesn't just look strange. It feels wrong, like something that doesn't quite belong. Arthur C. Clarke, the legendary science fiction author of 2001, A Space Odyssey, picked up on this exact vibe. In his novel 2001, the mysterious alien monolith is discovered not on the moon, but on Iapetus. He chose this moon for a reason. Its weirdness lends itself naturally to mystery, and maybe Clarke was on to something more than science fiction. Because Iapetus defies so many expectations, even as we continue to gather data, it feels like it's hiding something, some ancient story etched into its icy skin. It has no atmosphere, no weather, no liquid oceans beneath its crust, yet it holds more enigmas than worlds far more complex. It doesn't erupt or quake, but it speaks to us through its stillness. Even the orbital behavior of Iapetus adds one final wrinkle to its mystique. It orbits Saturn far outside the planet's ring system and other major moons, almost 3.5 million kilometers away. That's over twice as far out as Titan, Saturn's largest moon. It's also inclined at a steep angle compared to the plane of Saturn's equator, making it a true outsider in every sense of the word. Some have speculated that Iapetus didn't form with Saturn at all, that it might be a captured object, drawn into Saturn's orbit long after the planet's birth. If that were true, it could explain why it doesn't resemble Saturn's other moons. But if so, where did it come from? Perhaps from the outer reaches of the solar system, one of the ancient planetesimals that never quite found a home. Or perhaps from even farther out, beyond Neptune, from the Kuiper belt or the scattered disk. Some researchers have even wondered if Iapetus could be the remnant of a proto-planet, a small world that once had heat, movement, and ambition, now frozen in Saturn's shadow. All we know for sure is that it doesn't behave like any of its neighbors. It spins alone, tilted, dark on one side and bright on the other, with a ring of mountains slicing across its belly like a scar. But its most haunting feature remains that ancient mystery, first glimpsed by Cassini in the 1600s, the fact that every 79 days it seems to vanish. Not literally, of course. Iapetus doesn't disappear in the physical sense, but its dark side turns toward Earth, and the moon slips beneath our threshold of visibility. To the naked eye, to the telescope, it simply fades away. And in that disappearance is a metaphor, a celestial vanishing act, a world that teases us with its presence and then retreats into shadow, whispering through silence. T hears a strange reverence that settles in when we speak of Iapetus. Not fear exactly, but a quiet awe, the kind that creeps in when you stare at something that shouldn't exist and yet does, like a fossilized machine half buried in the ice, or a whisper in a language no one speaks anymore. Iapetus doesn't just orbit Saturn, it drifts through myth. Every anomaly, every contradiction in its surface and behavior seems to point toward a deeper question, one that refuses to be silenced. And that brings us to the lingering possibility that no one wants to say aloud, that perhaps Iapetus is not entirely natural. Yes, this idea lives on the fringes, but the fringe is often where curiosity grows best. It was in this very spirit that Richard C. Hoagland, a former NASA consultant and space theorist, famously proposed that Iapetus might actually be artificial, an ancient, abandoned construct left in Saturn's orbit for reasons lost to time. He wasn't alone. Other theorists have pointed to the moon's unnaturally geometric features, especially the equatorial ridge, and asked if we're looking not at geology but architecture. Let's be clear, mainstream science doesn't support this. There's no hard evidence of construction, no smoking gun pointing to alien engineering. But let's indulge the thought experiment for a moment. Imagine you're building a long-term stable observation post, something that can endure billions of years without atmosphere, erosion, or seismic activity. You'd want it somewhere cold, somewhere quiet, somewhere like Saturn's outer orbit. Now imagine cloaking it, half in darkness, half in light. Not just to blend in visually, but to maintain thermal balance, or even signal a pattern. And then you give it an axis-lock spin, always showing the same face to the planet it orbits. What would that accomplish? Perhaps nothing. Or perhaps constant surveillance of Saturn itself. That's the haunting thing about Iapetus. You don't need to believe it was built to see that it acts like it was, at least in some subtle architectural way. Its symmetry, its orbit, its clean split between light and dark, it all feels too deliberate, like a design left half-finished or a riddle never meant to be solved. And yet the true explanation may be even stranger, because natural processes, left to act over enough time, can produce things we'd swear were artificial. The way frost patterns mimic feathers, the way river deltas look like tree roots. Perhaps Iapetus is just the universe's most elaborate ice sculpture, a thing shaped by thermodynamics, gravity, and chance. A cosmic accident with perfect symmetry. But in that perfection, we can't help but project purpose. When Cassini finally made its closest pass to Iapetus in 2007, it snapped images that stunned the scientific world. Here was the ridge in razor-sharp detail, the shadows plunging into black canyons that seemed etched by something more deliberate than landslides. Here were the hemisphere, one reflecting sunlight like a beacon, the other devouring it like a well of ink. And here was the shape, slightly cuboid, even polygonal from certain angles, with crater rims that sometimes align just a little too neatly. No alien structures were found, no monoliths, no hidden entrances. But what was found was arguably just as compelling, a relic of solar system adolescence. Iapetus is old, possibly as old as the Saturn system itself, over 4 billion years. And in that time, it's kept its secrets. No molten core, no plate tectonics, no resurfacing. It's a moon that preserves history the way ice preserves fossils. And perhaps that's its true value. Iapetus is a window, not into alien technology, but into a past our own planet has long since erased. Earth is dynamic, always changing. But Iapetus is a frozen ledger, every impact recorded, every layer of dust a line in the diary of a forgotten epoch, which makes the mystery of its origin even more tantalizing. If it was captured, then where did it come from? Some suggest it was ejected from the Kuiper belt, migrating inward through chaotic gravitational interactions in the early solar system. Others believe it might have coalesced from Saturn's primordial disk, but under conditions unlike any of the planet's other moons. Either way, Iapetus is a traveler, a wanderer caught in orbit, carrying secrets from a time before Earth had oceans, and it's still drifting, still turning. Every 79 days we see it vanish, like the closing of an eye. And when it reappears, it's as if it never left. That cycle, that rhythm, it's hypnotic, like a cosmic lighthouse blinking through time. And maybe that's what it is. Not a message, not a warning, but a presence. A constant, whispering presence reminding us that the solar system is not as simple as we'd like to think. There are moons that erupt with geysers, moons that harbor oceans, moons that might even host life. But Iapetus is different. It does none of those things, and yet it haunts the imagination more than all the others combined. It's the silence that gets to you, the stillness, the impression that it's waiting for something, or maybe someone. For now, Iapetus remains just out of reach. No future missions are currently planned to revisit it. NASA and ESA have their eyes set on more active moons like Enceladus and Europa. And that makes sense. Those worlds offer potential signs of life. But in focusing on the living, we may be neglecting the dead, or rather, the dormant. Iapetus won't call out, it won't erupt, or shine, or glow. But it's still there every 79 days, slipping between presence and absence like a ghost at the edge of vision. One day, perhaps, we'll return, not with a flyby, but with a lander, maybe even a base, and we'll walk along that equatorial ridge, touch the dust that's never been touched, peer into craters that haven't seen light in eons. And maybe then we'll know, whether it was built or born, whether its strangeness is a message or just the cold elegance of nature on a scale we've yet to understand. Until then, Iapetus watches, a moon split by shadow and light, circling Saturn in patient silence, disappearing and returning in a rhythm older than civilization itself. And maybe that's why it haunts us, not because it's unnatural, but because it reminds us how little we truly know.